Hello everyone, I welcome you all for SVK tutorials. In this session, I have taken the topic called center of curvature and circle of curvature. I am going to define the center of curvature and circle of curvature. Also, I am going to give the relevant formula to find center of curvature and circle of curvature. So, before defining center of curvature, we shall consider a circle with center as C and radius R. Consider circle with radius R and center as C of x comma y. Okay, so in the circle, if you make any part, if you consider any part of the circle, we name that as arc. We name this as what? This is nothing but an arc of a circle. So in that way, I am going to consider in a plane, I am going to consider in an xy plane, I am going to consider an half of the part of the circle. I am going to consider half of the part of the circle. What I am going to do? I am going to consider half of the part of the circle. So this will be the center of the circle, that is denoted by C of x bar comma y bar. I will denote that as x bar comma y bar. So then I am going to consider a point P, as it is a plane with coordinates xy. So P of x comma y, and I am going to draw a tangent at that point P called PT. So this line PT is called as what? PT is nothing but PT is the tangent. PT is the tangent. PT is the tangent to the curve. To the curve. And if I join C and P, so that distance I will define that by rho. I'm going to define that by rho. And if I extend this line, and I will name this as point as n, Pn. So if I observe that Pn, it is looking as a perpendicular line to a tangent. Perpendicular line to a tangent. So therefore I can define Pn as what is the normal. So the normal is the normal to the curve at P, to the curve at P. So now we can define what is the center of curvature. If CP means from center to the point P is defined by the distance as rho, then C of x bar comma y bar is the center of the curvature, is the center of the curvature, is the center of the curvature to the curve, is the center of the curvature to the curve at P. Curve at P. Now we can define the formula for center of curvature in Cartesian form. Now if I want to define, then the center of curvature, for Cartesian form, for the Cartesian form or Cartesian curve is given by x bar equal to x minus y1 by y2 times of 1 plus y1 square, where y1 and y2 are derivatives. Similarly, I can find out y bar. Y bar is given by y plus 1 plus y1 square whole divided by y2. So this is the relevant formula to find center of curvature in Cartesian form, that is x bar and y bar. Once again, I will tell you how we find out the center of curvature. If you consider an curve, you're going to consider in general, you're going to consider a curve. So for that curve, you're going to have a center called C, and I will consider a point P. So draw a tangent at this point. So, and if I extend this line, that will be a PN, and from center to point P is distance is given by rho, and Pn is defined as normal. As we came to know that it is a normal to the tangent, then we can define the center of curvature at that point. If Cp is equal to rho, then then the then from point C is the center of curvature to the curve at P. Now we shall go for defining a circle of curvature given by this very simple form x minus x bar as x bar plus y minus y bar the both square equal to both. This is the general formula for center of circle of curvature. So I have defined center of curvature and circle of curvature with definition and a formula. So you can make a note of it. Thank you for watching my channel. If you have any doubts, you can put a comment, and those who are not subscribed to my channel, kindly get subscribed. Thank you all.